Right, guys, so this is a recording of a couple distance formulas. So the first one is how fast is an object going to be falling? Okay, and so I've written out the equations here at the top. Okay, remember how fast something is going to be falling is going to be, or the velocity is going to equal the gravitational constant, okay, which is g, which is most of the time we're just going to use 10, multiplied by the number of seconds that has been falling. Okay, and so a couple things that we're going to look from the word problem. Okay, and so basically what we know from this particular equation, right? So basically I drop a penny from the top of the tower of this place and it takes 2 seconds to hit the ground. Okay, and so now if I want to estimate, so first you want to draw a diagram of some kind. Okay, and so like for me, I'm just going to draw a very simple diagram, right? So basically it's just a tall tower of some height. Okay, I don't necessarily know how high it is, but I know how long it took for the penny to fall. Okay, and so right? So all I have over here, so then, right, so we're going to write out here the things that we know, okay, and the things that we need to know, okay, or things that we don't. Okay, and so I just go through and make this little chart. Okay, a couple things. I know my gravitational constant is going to be 10. Okay, I know the time in this particular problem, okay, is 2 seconds. Okay, and so now, okay, so if I wanted to find out how fast it's going, right, at the end of this, okay, all I would have to do is I would say that I would use the very top equation, okay, that velocity is equal to gravitational constant, or 10 times the number of seconds. Okay, and so if I know it fell for 2 seconds, okay, so then what we can say is right before it hit the ground, it would be traveling at, right, so I'm going to call it its velocity final, okay, just before it hits the ground, because once it hits the ground, of course, it's going to be 0. Okay, and so we're going to say that, right, is going to be equal to g, okay, I'm going to write my equation at the top, times 10. Okay, so our, sorry about that, g, or 10, times the number of seconds, which is just 2 seconds. Okay, so g, which is equal to 10, so we're going to have 10 times 2, which my final velocity is just going to be going about 20 meters per second. Okay, and so I'm going to move that down here so that way I have a little bit more room. Okay, and so that penny is going to be going right at the bottom. It's going to be going 20 meters per second. Okay, because it's telling me that it fell for 2 seconds. Now that we now can calculate. So I'm going to move him over into the known category. Okay, so things that we don't know, right? We don't know how tall the tower is. Okay, and so I'm going to put over here, right? So I'm going to draw myself my little diagram. So I know that you got a little guy standing on top of the tower, and he's the one dropping the penny. Okay, so I'll just do a little guy down here, and he's dropping a penny that's falling all the way to the bottom. Okay, and the thing is I don't know how tall this is. Okay, over here. Okay, so we're gonna put, this is gonna be the tower height. Okay, I'm just gonna make that h. Okay, for the tower height. Okay, so I'm gonna say I don't know the tower height. Okay, I'm gonna be looking for that. Okay, and so right, I can find the height of the tower, okay, by using my second equation down here. We're going to call this, right, so I'll put numbers on these. So I'm going to call this, right, equation number 1, and this is equation number 2. Okay, so if we're trying to find how far something went, then we're going to use that equation. Okay, so then I'm going to go down here. Okay, I know it fell for 2 seconds. Okay, so then I'm going to take my equation, I'm going to write it out up here. So distance is equal to 1/2 of 10. So I'm going to write out the whole equation. 1/2 g times the time squared. Now, if I know that, right, half of 10 is just going to be 5, so I'm just going to start writing out my numbers. Okay, so I would write out half of 10. So distance is going to equal half of 10, which is just 5, times the time squared. Time was 2 squared. Okay, so I'll put that in parentheses. Okay, so then all I'd have to do is I do my, remember PEMDAS, you do that one first, so you're going to have 4 times 5. Okay, and that's of course going to equal 20. Okay, so what I can say is that building is not very high. Okay, it is 20 meters tall. Okay, and that's how I can figure it out. Now, the question actually asked down here at the bottom, it says, calculate how fast it was going after 1 seconds of free fall. Okay, now to answer that particular part of the question, right? So, right, all I would need, I'd say, well, all you'd have to do is literally move the decimal one spot to the right. Okay, so for this answer, it would be going 11 meters per second. Okay, because it was only falling for 1.1 seconds. Okay, and so that's kind of a long description. I kind of went over both of them, so hopefully that helps.